Beneath the Earth's surface, large quantities of heat are stored as geothermal energy. The heat comes from the decay of natural radioactive material and is transmitted to the surface from the molten core of the Earth. Some porous rocks contain underground reservoirs of geothermally heated water. These aquifers provide a renewable source of energy, provided the rate of heat extraction doesn't exceed the rate of replenishment. In Tuscany and the Paris Basin, hot water from aquifers is used mainly for space and water heating. In parts of the western United States, the underlying rocks aren't porous but heavily fractured. Water rising through the hot rocks into boreholes provides an economically viable source of geothermal energy. When the pressure's released, the superheated water turns into high-pressure steam. This is then piped to the geothermal power plant, where it's used to turn turbines and generate electricity. Just outside Sulz, near Alsace on the German border, there's a project that aims to extract the heat from hot, dry rocks to create electricity.
There is a vast amount of energy available. Something like 70% of the Earth's surface has got granite at depth. Granite's got a very good conductivity, therefore the heat transfer is much higher. An average conduction is something like 30 degrees per kilometer. The idea is to create a heat exchanger in order to extract energy from underground.
But to extract the heat, the rocks must be fractured and water pumped through the fissures.
First thing is you drill a borehole to the depth of 5 kilometers. Then you measure fundamental things like stress, jointing, other geological properties. Once you understand it, then you inject fluid under high pressure and you open up existing joint network and you track where this opened up joint network is by listening to it from seismic sensor.
Water is then pumped into 2 wells and steam collected from a third. This will then drive the turbines.
This is only one module. There is absolutely no reason why I should not replicate this to 5, 6, 7 modules and increase your output to up to, say, 50 megawatt if you want to.
Research continues, backed by several European countries, in the hope that this energy source might become economically viable in the longer term.